Hello, fourth grade mathematicians. This is Mrs. Baker here with our part 2 lesson of finding the area of really complex figures. So today's learning target is I will be able to find the area of complex figures. The materials you will need is that distance learning math packet. We will begin on page 37 of that packet. You'll need a pencil and 3 light colored pencils, since now we're splitting our complex figures into 3 different rectangles instead of just 2. All right, so let's get started. Please open that packet to page 37. It should look like this. We are finding the area of really complex shape B. You can see here that some of these side lengths are really quite large. And so we're going to need a really big graph, and those graphs are found on those extra pages in your packet. I'm just going to switch ahead to a bigger graph for myself. And so our first step then is to draw our shape on that grid paper, remembering that we need to leave ourselves enough room to draw the entire figure, starting with an outermost corner of that figure. So I'm going to start way down here. I happen to know this will be big enough. So I'm going to start way down here. You would start at the bottom of your grid, but if I do that, you won't be able to see my shape anymore. And I'm going to go up this length of this side, 19 inches is our unit. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I wish I could draw straighter. 11, 12, 13, 14, 15, 16, 17, 18, 19. Now that can play tricks on your eyes. So I'm just going to double check and truly make sure I have 19. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I do. Okay, shoo. All right, so here's what I want you to do. I want you to pause the video. I want you to go ahead and draw the rest of your shape on your grid paper and then come back and we will work to solve. Okay, welcome back. So now we have our figure drawn on our grid paper. Knowing our lengths here, our next job is to split this figure into 3 rectangles so it is so much easier for us to find the area. So there are a couple ways you could do it. You could choose to split it horizontally into 3 different rectangles. That's one way to do it. The other way to do it is to do it vertically. So we have 1 rectangle, long tower here, and 1 long tower here. So those are our 2 choices of being able to split it. I think I'm going to choose the first way. I'm going to go ahead and I'm going to split it horizontally this way and this way. So I have rectangle 1, rectangle 2, and rectangle 3. And I'm going to go ahead and use my highlighter to make them different colors so it is so much easier for me to figure out the area of each one. Coloring doesn't have to be absolutely perfect, just so that it shows the separation of the different rectangles. And then we'll use this blue down here. Okay, so we have rectangle 1, rectangle 2, and rectangle 3. So we have 2 choices here. We can count here, or we can also use the numbers that have been given to us in the original figure. So I'm going to use the ones that I see over here. I happen to know that this top line right here is 7 inches. So 1, 2, 3, 4, 5, 6, 7, just double checking my counting. There's 7. And I see this little side right here is 3. 7 by 3. So I'm going to write that right in here. That's my first rectangle. 7 by 3, and I can go ahead and draw this here too, just to represent that that's what I did in my grid. Now for rectangle 2, I have a long length here, and there is no actual length over here that matches that, because I also have, if I do this, this little piece I'm not using. And so I have this 19 here. And so this, at this point, I'm probably going to have to count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 on this side. So 15 on this side. And then I know that this length right here is 7, this little one, but that's not the whole one. It goes all the way across. So I should probably count that. I know this is 7, 8, 9, 10, 11, 12, 13, 14. So that one is 15 by 14 is that second rectangle. Now that third rectangle, my blue one, I know this side length right here. It's right here. It is already written for me that that is 4. And I know that that bottom length all the way across is that 20. So that would be the area, the numbers I'd need to find the area for that third rectangle. So that is 4 times 20. Now I'm going to go ahead and do the ones that I know right away. So 7 times 3. Well, that's 3 groups of 7. So 7, 14, 21. Rectangle 15 by 14, I cannot do that one in my head. I'm going to have to figure that one out. But I'm going to go ahead and skip to the one I do know, the 4 times 20. 4 times 2 is 8, and I've got that 0, so that would be 80. So now I'm going to need to do a little extra work to find out that 15 times 14. So I'm going to do that on a blank piece of paper here. And I'm going to go ahead and use my area model. 15 times 14. I'll write that right here so I remember. So that is 10 plus 5 times 10 plus 4. All right, so now I need to do that math. And I have in this little box 10 times 10. That is 100. And then I have 10 times 5, which is 50. And in this bottom row, now I have 4 times 10. I'll write that here so I remember. And that is 40. And then I have 4 times 5, which is 20. So my final step is to add all 4 of those numbers together. I have 100, making sure I am lining them up correctly by place value so it is easier to add. So I have 100 plus 50 plus 40 plus 20. So in the ones column I have a 0. 5 plus 4 is 9, plus 2 is 11, carry the 1, and 1 plus 1 is 2. So 210 is my answer to 15 times 14. So I'm going to go ahead and go back and write 210 in my answer. Now I did try to line them up, but if I need to rewrite them, I can. I always like to put the biggest number on top and rewrite them maybe up here to find out the total area now for all 3 rectangles put together. So we have 0 plus 1 is 1. 1 plus 8 is 9, plus 2 is 11. Carry the 1. 2 plus 1 is 3. That means that the total area of this figure is 311. And now I'm looking at the figure and we are given the units. So it would be 311 square inches. And we can abbreviate inches by just putting an IN. So that would be the answer for the total area of that first complex figure. All right, we're going to do another one. This one is found on page 41. So you're going to skip ahead past a couple sheets of grid paper. Whoops, sorry about that. And this will be area of shapes made of 3 rectangles. This is, like I said, page 41 of your packet. And you're going to use the attached grid paper in your packet to do the work on this one. Now this one, I want you to notice this, 23 and 21. This is a really big figure. So we're going to make sure that we are giving ourselves plenty of space to draw on our grid. So we're going to start, way at that top right outer corner, right up here on our grid. And we're going to go ahead and draw our complex figure. So go ahead, pause the video now to get yours drawn, and then come right back when you're ready. All right, hopefully you double checked your counting after you drew your lines. I know I did. Like I said, all those boxes can play tricks on your eyes. So make sure you double count and make sure you have that correct. Okay, once again, we are given a complex figure here and we need to split it so it is so much easier to find the total area for. And looking at this, I know that I can split it into 3 different rectangles. And once again, I have a couple choices of how I want to do that. And I want to remind you too that we don't want to chop it up into too many different rectangles. We could do that if we wanted to. Some people might be tempted to do so many more, as Ms. Lewis talked about yesterday, but we don't want to do that. We want to make this easier on ourselves. And so there are a couple ways that we could do that. And this is the way that I'm going to choose for today. We could do this, go across horizontally, or you could have chosen to split it vertically, like this. And so either way works. I might as well just keep it this way since I just drew those lines, and I'm going to go ahead and highlight each rectangle into a different color so that it is easier on my eyes when I am doing the counting and trying to figure out the side lengths so that I can figure out the area for each rectangle. So we've got a yellow one, a green one, and then we'll make this that pretty color blue. So here are our 3 rectangles. Go ahead and shade yours in if you haven't yet. Just makes it a little bit easier to determine the area by separating them. Okay, so we are ready. So I am going to call this one rectangle 1, this one rectangle 2, and this one rectangle 3. All right, so now my job is to figure out the side lengths of each one. And so I'm looking over here. I've got this side here, and it's already recorded for me. So that's 5 feet. Now it is this side and this side. So they are recorded right there for me by being 7 feet. So that first rectangle would be 5 by 7 feet. The second rectangle, now this is part of a whole long side. So I'm going to look at the bottom. The bottom here is also recorded for me right here on this figure. It's 8 feet long. What I don't know is this long side of this second rectangle. I do know that this part of it is 9 because that's recorded for me right here. So I know that's 9. And then I can count up from here. So 10, 11, 12, 13, 14. So this rectangle is a 8 by 14 rectangle. So I'm going to record that here, 8 times 14. That's what I'm probably going to have to do on a separate sheet of paper. And then my final rectangle, rectangle 3, I know this length because it's recorded right here for me. That's 8 feet. And I do know this long side here. It's recorded right here. That's 21 feet. So that last one will be 21 by 8. All right, so the last step, 5 times, or not the last step, but the second to last step, I need to find the answer to the area for each of these rectangles. So 5 times 7, well, I know that that is 35. So I'm going to write that right here. That's 35. 8 times 14, I'm not sure of. So I'm going to go to a separate sheet of paper, and I'm going to do my area model. So I have 8, I write that here, times 14. 8, 10 plus 4. All right, so 8 times 10, I know that's 80. And 8 times 4, I know that's 32. So I add those two together, and I get 112. So 8 times 14 is 112. I better record that. And then the last one, the 21 by 8, I'm going to go ahead and figure that out here as well. So I, once again, have times 8, but this time it's 20 plus 1. 8 times 21. All right, so 8 times 2 is 16. Put that 0 there. And 8 times 1 is 8. So that is 168. So rectangle 3, whoops, I just already forgot it. 168 was 168. So now to find that total area, I'm going to go ahead and add them up. 168, 112. Whoops. I got ahead of myself. I'm not done yet. 112 and then 35. So adding those together, 8 plus 2 is 10, plus 5 is 15, carry the 1. 1 plus 6 is 7, plus 1 is 8, plus 3 is 11. 1 plus 1 plus 1, 3. So the total area would be 315 square, and I do have a unit, it's square feet. So I better highlight that since it's running into each other here. My answer would be 315 square feet. Now we have one more on this page. I'm going to challenge you to try and figure this one out here. Pause the video, see what you get, and we'll come back with the answer in about a second here. All right, welcome back. So this is how I solved my area of this complex figure. I split it into one big rectangle on top and two smaller ones on the bottom. And so rectangle 1 I found to equal 312 square inches. Rectangle 2, 110 square inches. It was 11 by 10. And then that last rectangle was actually a square, 7 by 7, so it was 49. When I added all of those together, I got 471 square inches. All right, fourth graders, let's check our learning target today. Able to find the area of complex figures, and we did that. We found it of 3 different complex figures. Good work today, and happy solving.